Now, we are going to talk about yields and the generator. Specifically, in this session, we'll mostly talk about the generators, right? But before we talk about the generator, right, let's first implement a simple iterator what we have already seen in the previous sessions, right? So here, first let's import the math module. Here we are creating a iterator for the factorial class. We have the init method, we have implemented the iter method, and here is the next method which gives you the result of the next factorial, right? And then if it is passes through this n value, so this will stop the iteration. So we have this fact iter function, so we have created the iterator over here for the factorials. Now let's run this. Now to call this, here we are getting fact iter, we are passing 5. 5 is for the n, right? So when we run this, this is the iterator now. Now we can iterate this in a loop. We can simply call the for loop over here. Here we can see that we have iterated the value, right? So we can achieve the same thing using the iter method of the second form. For that, we need a simple functions, right, without iterator. So here we have this simple functions fact which will create the iterator. So sorry, we have this simple function fact which will give you the factorial of any value, right? So here we have these functions, right? We can check how the iter function work. What is the second form of the iter is? When we call the iter, we can see that this is the second form of the iter. That means this need a callable as a first argument, and as the second argument, this need a sentinel, right? Where we, so it's like n value over here. This is sentinel is something like n value, right? So we'll be using this iter second form. Here we are passing the factorial and this is the sentinel value. Now this iter function will create the iterator. This is the iterator now. And here when we take this in a loop, right, we'll have the factorial till 1 to 24. So we have achieved the same thing with the iter functions, right? But again, with this function, we have the lesser code, right? But there has to be a better way. And of course, the generator is the one of the techniques we can use for this task, right? For that, we have now in generator we mostly see the yield statement. Now let's first see what the yield statement is. So yield statement is being used like the return statement in the functions, but there is a huge difference between yield and yield and the return statement. Now when the yield statement encounters, Python returns whatever value yield specifies, but it pauses the executions. So that means when this matches the yield statement, this whole function has been paused out, right? It has the value in the yield statement. Because of the yield statement, it has the value, it has calculated the value, but it has not executed the function. It has paused the function when it reaches the yield statement, right? And then we can call the same function again, right? After we call it, it will resume from the last yield that was encountered. That means here we are calling that, here we are saying that we have to call the same function again, because for to call it we have to use the next function, right? Yes, so the next function is the same function which we use for the iterator, right? Now here is a function. Now consider that a simple function, my func. We have the print, and then we have this yield. Again we have the second print, again we have the second yield. So when now we have defined the function, now when we call this, what happens over here? When we call this, it gives you the generator. This is a generator object we are getting at this address. So it did not actually run the body, like it does not executed this entire path. So when it matches this, then it matches this. When it matches this yield, it has paused itself, right? Now to run this, we need to use the next function. Next function for the calling or for the next iterations. So let's first create the object of this my functions, which will give you the generator. Now this variable will hold the generator object. Now when we call the next, it will print the line 1, and then it will call, and then it will give you the flag. Now see, it has not printed this line, it has printed line 1 and then it has matches yield, and that's it. It has paused it, right? Now again when we call this, again when we call the next, it will again print this and then it will give you the yield statement here. So we have to call the, every time when it matches yield, we have to call it again and again, right? When we again call this, when we again call this same iterator, we'll get error. And then error we are getting as in the stop iterations. So we have the stop iterations to, so it has automatically stopped the iterations. We have not implemented it. And to call the function, we need the next statement. So we are using next and the iteration. This is like an iterator. Actually, generator is the iterator object, right? Now, if the generator or iterator, they should implement the iterator protocols. Like we are saying that it has both term, it has the next function, like the next is like it has implemented the next, it has the implementation of stop iteration. That means it is the iterator. And if it is the iterator, it has the iterator protocols. That means we have the iter and the next method. This is what we're talking about. And yes, it is. So we can check that. We can check that if there is this function available or not. We have this. We even have the next method implementation with this object. So as we saw that, so when we use with the iter and the next function, like the iterator, right? So we know that, right? We can use the iterator and the next function both in this generator object. So when we call this object, what we are getting, again, we are not calling it. We are just trying to see what the object is. It is giving you this generator object. And when we again call the iter method over here on the same object, we know that iter method gives you the same object. So it will give you the same object. Here we can see the address. It is not created the another object. It has given you the same object, right? So it's the iterator. If this is an iterator that Python builds, so how does it know how to stop the iterator? So again, it has this stop iteration implementation in it, right? And actually, when it matches the yield, and let's say that when it finishes with the yield, like when there is no more statement that runs after the yield statement, like over here, we had this to yield, the last yield was this, but we have never implemented how to stop it, right? So it's like when we again call the next function, it is giving you the stop iteration. That means deep down it has implemented that, and we know that when we do not have to return anything, like here this function does not have to return anything, it is not returning anything, so by default it will return none. We know that any function will return none, right? Because this function return none, so Python has implemented that if it returns something, anything, if this generator returns anything, it has to be terminated. So this termination of the stop iteration is happening because of the return statement. It is not with the return none, it is with returning anything. If it return anything, this will terminate, right? So here consider these examples over here. Here in this example, everything is same, but here we are returning all done. So earlier we were not returning anything, but here we are returning all done. Let's run this. Here we are getting the generator object. We can call this next function. Again, we are calling next. Again, we are calling next. Now when we call next again, this will say stop iteration and then it is printing all done. This means that this print is happening because of the return statement. So whatever is returning, that becomes the message for the stop iteration and the generator, right? We can even slightly simplify the functions, right? Like here we have the square functions, right? Now we are getting the object, and because this is the iterator, so we are taking this in a loop. We can run this. This is working, right? Now we can see how we can rewrite our factorial examples. This was our factorial yeah, so this was our square example, but let's see how we can rewrite our factorial examples. So here we have the factorial functions, which we have implemented the loop, and then every time when the loop runs, it creates the factorial of that value, right? And we are not returning it, we are yielding it, right? So when we run this, like when we take this in a loop, every time it will calculate the factorial value, right? And then it will give you it will return you the value. And then when it does not has to return, when there is no return, like because we do not returning anything, so this will break, right? Here we are getting the output, right? So the generator is the iterator, now we know, but it is not vice versa. Iterator cannot be the generator. It is similarly the sequence are iterator, but sequence are iterables, but the iterables are not sequence, right? It is the same way. And another thing to note that since the generator are iterator object, they can also be exhausted. That means if there is nothing to be printed, it will give you the empty value. Like here we have the factorial of 5. When we call the list of factorial, we have calculated all the factorial value till 5. And when we again call the list of fact, this will give me the empty list. This is similar. This is like similar behavior as an iterator. But again, when we call the next of fact, we know that this will break and this will give you the stop iteration error. Right? So this is it. This is a basic introduction of the generator and the yield statement. Thank you very much.